This is our circuit 6 video, and in this video I will try to solve as many circuits, different types of circuits as I can, so you see a lot of practice and can try practice on your own as well. So these are the lessons from our online lessons, and the circuits you see here also from online lessons. So it's I'm just following the lessons that I will do with you in the classroom. So let's look at number 31 right here. We have the current is given and 3 resistors are given, 2, 3, and 6 ohm. So I see the 3 resistors in parallel, and I can find the total resistance. The total resistance is 1 over, and 1 over. Then our result is going to be flipped over. The common denominator is 6. So for the first fraction, I don't have to do anything. For the second fraction, I have to multiply the numerator and denominator by 2. And for the third fraction, I have to multiply the numerator and denominator by 3. So what I get is 6 over 6. And if I flip it, it's still 6 over 6. So the total resistance of the circuit is going to be 1. So I can redraw the whole circuit as 1 ohm resistor, and I have the current that they tell me is 6 amps. And let's go ahead and call this point A and this point B. So here I have point A and I have point B, and I replaced all the resistors with just one equivalent resistor, 1 ohm. So the voltage is equal to I times R, Ohm's law. Your current is 6 and the resistor is 1, so the voltage is 6 volt. So now I know that the battery is 6 volt. Because all of them are connected in parallel, every single one of them shares the same 6 volt. And to calculate the current, so the voltage between point A and B is 6 volt. So this is point A, and this is point A, and this is point A. So every single one of them is A. And this is point B, and this is point B, and this is point B, because there is no resistors in between the points. So every single resistor has the voltage of 6 volt, and the voltage divided by the resistance will give me current. So 6 divided by 2 gives me 3 amps. 6 divided by 3 gives me 2 amps, and 6 divided by 6 is 1 amp. And if you add every single amp, you get 6 amps, and that is how many amps you had. So there were 6 amps running this way, and then 3 of them went in this direction, 2 of them went in this direction, and 1 of them went in this direction. The sum of all the amps will give you 6 amps. Here's the next question in our lessons online, and here I have 6 ohm resistor and 3 ohm resistor connected in parallel. So I'm going to replace these 2 resistors with 1 resistor. So I'm going to place 1 resistor, but I need to calculate the total resistance of those 2. Because they're in parallel, I'm going to do 1 over the result flip over. So if I add these 2 fractions, I'm gonna get times by 2 the top and the bottom of the second denominator, fraction, numerator denominator by 2. I get 3. The total resistance is 2, so this is 2 ohm. And then the rest of the circuit, I have still 2 ohm and 3 amps running this way, and then the voltage is not given. So because 2 resistors now are in series, all I have to do is just add them. So if I add them together, the total resistance of the circuit is going to be 4 ohm, and then I have the battery, and the current is 3 amps that is given. So then I can calculate the voltage is equal to I times R, and that will give me 12 volts. So now I know that the voltage is 12 volt, and the current right here is 3 amp. 3 amp will split, some of it will go this way and some of it will go that way, but again they will unite, and when they come back there's going to be 3 amps running through the resistor that is 2 ohm resistor. So I'm going to have 3 amps right here again. 2 times 3 will give me 6 volt. I started with 12 volts. So when my aliens or my amps are leaving the battery, there's 3 of them leaving, and all they have is 12 volt in their packet. So by the time they get back home, they have to spend 12 volts. They spend 6 volt over here on this resistor. So it doesn't matter which path they choose, whether they choose the top resistor or the bottom resistor, they have to spend 6 volt between, let me do them in the red color, between these 2 points. So if they spend 6 volt, whether they went through the top resistor or through the bottom resistor, then they spend another 6 volt through the last resistor and then get back to the battery. So I know that if between these 2 points, and here I have 6 ohm resistor, and here I have 3 ohm resistor. So if I know that between these 2 points I do lose 6 volt, then the voltage divided by the resistance will give me the current of 1 amp, and the voltage divided by the resistance will give me the current here of 2 amps. So there were 3 amps coming from the battery. Then again 3 amps united and went through this resistor, and you lose 6 volt either way you go, this resistor or that resistor, and then you lose another 6 volt on this resistor, and you lost all 12 volt through each resistor. So the current through the top resistor is 1 amp. Maybe let me erase it and rewrite it one more time. So you had 3 amps, they split through this one is 1 amp, through this resistor you get 2 amps. The voltage is the same for both of them, so between the point here and the point over here you spend 6 volt. You also spend 6 volt over here, or drop 6 volt, and the current again 3 amp through that resistor, and the voltage was 12 volt. Let's look at the next question. So here we have the voltage is given and all the resistors are given. So I can find equivalent resistance and I will know the current through the first resistor. So I just placed it in red. I will know that current. So let's do the total resistance. I see parallel resistors. So I will calculate the total resistance of the parallel, and then I'll only have the series circuits. So at first, I'm gonna rewrite those 2 parallel resistors as 1 resistor and find its resistance, the total resistance, or the equivalent resistance. And then I have the first resistor, I have the battery, and I have 1 more resistor. So the first one is 3 ohm resistor, the last one is 1 ohm resistor, the battery is 48 volt, and I will find the equivalent resistance of those 2 parallel ones. So for parallel I have 1 over 1 over, the result flip over, so I have 1 over 3 plus 1 over 6. The result is going to be 3 over 6, so the total resistance is going to be 2. It's 1 over 1 over, the result flip over. So I have 2 ohm resistor for the equivalent of those 2 resistors in parallel. Then I'm going to rewrite this circuit as all resistors together. So I'm going to combine every single resistor and place 1 resistor instead of all of them. So I have 1 resistor, and then I have the battery. so the battery is still 48 volt. And the total resistance of all resistors in series are connected, so 3 plus 2 plus 1, I just have to add them, is gonna give me 6 ohm. So from here I see that from the Ohm's law, V is equal to I times R. So I is equal to voltage divided by the resistance, which is 8 amps. So I know that the current that is leaving from the battery is 8 amps. And right here I have the current 8 amps. So this current, the first one, is 8 amps. Then this current is gonna split between the other two resistors in parallel. And then by the time it gets together, so it will combine into together through one line. And then right here you will have the same 8 amps. That will give you the voltage on this resistor. The voltage is I times R, so that gives you 8 volt. And the voltage on the first resistor is again I times R, so 8 times 3 gives me 24 volt. The total voltage you had is 48, so 24 volt and 8 volt will give me 32 volt. So what I'm missing is 16 volt because the total needs to be 48. So if I add all the voltage, 24 and 8, that gives me 32. I'm missing 16. So these two resistors in parallel share the same voltage, and that voltage that they share is 16 volt. So now if I have 16 divided by 3, that will be the current through this resistor, so that is 16 divided by 3. And if I have 16 divided by 6, that will be the current through this resistor, so that is 16 divided by 6. 16 divided by 3 and 16 divided by 6 should give me 8 amps that split. Remember, like we had 8 amps leaving the battery, and then they split between those two parallel resistors. So together should give me 8 amps. So the common denominator is 6. I just want to make sure that I did my calculations correctly. Times by 2 the numerator and denominator of the first fraction. So I get 32 plus 16. So that is 48 divided by 6, which gives me 8 amps. And so I solved for all the currents and all the voltage on every single resistor. Here we have the next circuit, and you see the red dots. I'm gonna call these points A and B, and the green dots, see here are the green dots. Between those two, the bottom one is the same B, but the green on the top and A is different. Maybe I'll call the top one is C. But because there is no resistor between B and B point, so it's the same B point. What I see in this circuit is two parallel resistors right away. So if I notice two parallel resistors, I'm gonna get rid of them. So instead of those two parallel resistors, I'm gonna make one resistor. I have to calculate its resistance. So I have again 1 over plus 1 over. The result flip over is going to be 2 ohm as before. So we have 2 ohm resistor. None of these resistors are real. In real life, you will never have resistors like this. But I'm just teaching you the technique of how to operate the resistors in parallel and series to solve for the values of the currents and resistors in parallel, in series, or combinational circuits. So here we have again your B point. This is your B point, and this is your C point, and this is your A point. And the resistors are 3 ohm, 4 ohm, and 2 ohm. And the voltage is 12 volt. And I again, so I went from that circuit to this circuit, and I can still simplify this circuit a little bit because I see that, maybe I'll do them in green. These two resistors are now in series, so I'm going to replace them with one single resistor, and that resistor is going to be 6 ohm, and then I have again 3 ohm resistor, and I have the battery, which is 12 volts. And because this point C and this point B connected straight to the battery, I know that they share the same voltage. So both resistors right now, the ones that you see all the way at the bottom, both resistors share the same voltage, 12 volt. So 12 volt divided by 3 ohm will give me the current in the 3 ohm resistor, which is 4 amps. And 12 volt divided by 6 ohm is gonna give me 2 amps. So I know that there is 6 amps leaving the battery. So there's 6 amps leaving the battery. So right here I can write, I'm gonna erase my points. So I'm gonna write right here, there is 6 amps. And between the points for the first resistor we have 12 volt, so we said that that one is 4 amps and the voltage is 12 volts. So when the aliens or amps leave in the battery, some of them will choose to go through the first resistor. They will spend all 12 volts in the first resistor and then come back home. But some of them will choose to go through the second resistor, through the 4 volt resistor. And from point C, so here is your point C, from point C I see that it's going to be 2 amps going from point C. So I know that this is 2 amps, and if that is 2 amps, then I times R will give me 8 volt, and the total voltage is 12, and I'm losing 8 volt on this resistor. So what's left for the other two, so the sum of the aliens or the amps will decide to go this route through this resistor and then back home. So they have to spend 12 volts, the ones that they got from the battery. So if they are spending 8 volt on the resistor on the top, then there is only 4 volt left right here. And because these guys are parallel, you have 4 volt for each one of them. It's the same 4 volts. So the current through 3 ohm resistor, you have 4 divided by 3, which is, I'm just going to write 4 divided by 3 amps. And the other one is 4 divided by 6, which is 4 divided by 6 amps. And right here we had 2 amps. 2 amps through the 4 ohm resistor. Then they had to split here and here. So that means 4 over 3 plus 4 over 6 should give me 2 amps, the ones that are splitting. So the one that I have right here, this is 2 amps, and those 2 amps have to split. So if I add them now, so times it by 2, times it by 2, the common denominator is 6, and I have 12 on top, so I have 2 amps. I'm just checking my work because these are like puzzles. If things are falling out correctly at the end, then you know you solved the problem correctly. Just to go over my results one more time, I will have 6 amps right here. This resistor shares 12 volt with the battery, so that is 12 volt. And the current is 12 divided by 3 gives me 4 amps. Then the current that we said went straight to the 4 ohm resistor is 2 amps, and 2 times 4 gives me 8 volts. 8 plus another 4 volt, they share the same 4 volt for both resistors, so these two resistors share the same voltage. Maybe I'll do them shaded in different way. So these two resistors share the same 4 volts, and the current that I'm calculating for each one of them is the voltage divided by the resistance. That gives me the amps of first resistor, and the voltage divided by the resistance gives me the current through this next resistor. And together these two resistors should give you the current that was 2 that was going through the 4 ohm resistor. Let's look at this circuit. So we're going to simplify it again. I see 2 resistors in parallel. So this 2 ohm resistor and this 2 ohm resistor, I'm going to replace them with 1 resistor. So I'm going to place 1 resistor right here. The total resistance of this resistor is going to be parallel connection. So it's 1/2 plus 1/2 is going to be 2/2. Result flip over, it's just going to be 1 ohm resistor. Then I have the last resistor, which is 5 ohm resistor. And then I have 2 ohm resistor and 12 volt battery. And then we have 3 ohm resistor and 12 volt battery. Now I see that on this line I have 2 resistors in series. They're sitting on the same line between 2 points. I can call this point A, and I can call this point B. And so this I have A, and this one is B. So now I can redraw the new circuit into different circuit because they're in series. All I have to do is to add these 2 resistors. So maybe I'll just make them a different color. So this resistor and this resistor will be added together, and that will give me 6 ohm resistor. And then I copy the rest of the circuit. So I still have 2 ohm resistor. I have my battery. Here is the point A, here is the point B, and I still have 3 ohm resistor and 12 volt battery. Now I see 2 resistors in parallel. So this resistor and this resistor are in parallel. So I'm gonna redraw my circuit again. And I have to do 1/1 the result flip over. So 1/3 plus 1/6, the result flip over is going to be 2. So I will have, instead of those 2 resistors in parallel, I will have 2 ohm resistor. Then I have another 2 ohm resistor. Here is still my point A. Here is point B. And I have the 12 volt battery. Now I have these 2 resistors in series, so the total resistance is 4. Then the current, V divided by R, gives me 3 amps. So coming back to the problem that I originally had, I see that there is going to be 3 amps for the current, and I times R will give me the voltage. So 3 times 2 will give me 6 volts. I have 12 volt to start with. I give away 6 volt on the first resistor. So for any amps that decide to go through this resistor, the green one, they have to give another 6 volts, and they go back home. So the ones that choose to go through the green path will give 6 volt, and back home. So I know the current that went through the 3 ohm resistor, the voltage divided by the resistance, gives me 2 amps, but there were 3 of them leaving the battery. So I have the current right here, 3 amps, and 2 of them went through this route. That means 1 of them went here between those 2 blue resistors in parallel, and then connect and give me again 1 amp. So 1 times 5 gives me 5 volts. But between point A and B, we said we have to lose 6 volt. So this was point A, this is point B. So I had to lose 6 volt between those 2 points. That means I'm losing 1 volt between those 2 parallel resistors. Doesn't matter which one you choose, the top resistor or the bottom resistor to walk through, you have to pay that 1 volt. So it's the same 1 volt for both of them, but I'm just going to write 1 volt, 1 volt. And 1 divided by 2 gives me the current of 0.5. So the top resistor is going to have the current of 1/2. And the bottom resistor is going to be having the current of 1/2. So they split the same current of 1 amp. I'm going to erase this voltage here. So this is 1 amp coming into the split between 2 resistors in parallel, and 1/2 of an amp is going to go through the top and 1/2 is going to go through the bottom. And because they're the same value of 2 amps, they split the current evenly, so it's 1/2 and 1/2. And then they unite, and it's going to be again 1 amp that is going through the last resistor. Here's going to be our last problem for this video, number 6 for solving circuits. And I see 2 resistors in parallel right away, so I'm going to color them green. And it's 1/2 plus 1/2 result flip over is going to give me 1. So I have 1 ohm resistor instead of those 2. And then I have 3 ohm resistors still. And then I have 4 ohm resistor. And right here is 1 ohm resistor. So let me write their values right here. So 12 volts, 1 ohm, 4 ohm, 3 ohm resistor, and 1 ohm resistor for the last one. Then this resistor, 3 ohm, and 1 ohm resistor are now in series. So I can rewrite them again as 1 resistor. And just add them together. That will give me 4 ohm. And what I still have left is 1 ohm resistor and 4 ohm resistor and the battery. And here I see that these 2 resistors again in parallel. So I can rewrite them, so I'm following in this path, right? From this circuit to this circuit. Then next one is going to be, maybe I'll just go scroll down here. And so those 2 resistors are in parallel, so I will have 1/1/, the result flip over. And that will give me 2 ohm. So I have 1/4 plus 1/4, the result flip over is going to give me 2 ohm. And then I have 1 ohm resistor and the battery. And the battery is 12 volts. So now I can go to the next circuit and combine the last 2 resistors together. So that will give me 3 ohm resistor for these 2 guys together. And so this is the last resistor. And then I have the battery. And this is 12 volts. So the current now to live in the battery is the voltage divided by the total resistance, which is 3 ohm, gives me 4 amps. So I can go back to my original problem and plug in 4 amps for the first resistor. So right here I have 4 amps. And 4 times the I times R, which is 1, will give me 4 volts. I have 12 volts to start with, and I lose 4 volts on the first resistor. So if I lose 4 volts on the first resistor, then only 8 is left for the last resistor, or the one that the next resistor in this path. And 8 divided by 4 gives me 2 amps. I had 4 amps and 2 went through the 4 ohm resistor. That means the other 2 amps will go through another resistor. And 2 times 3 will give me 6 volts. So if you go through this path, you lose 4 volts, and then you go forward, and then another green resistor that I'm shading, that one is gonna lose 6 volts. Then the last 2 resistors will share exactly the same 2 volts. And 2 divided by 2 gives me 1 amp, and 2 divided by 2 gives me 1 amp. So it looks like these 2 amps will split into 1 amp and 1 amp. I think I have to finish the video right now. I'm running out of the time. It gives me only 30 minutes per video. Thank you for watching this video, and I will see you in the next one.